Bismillahirrahmanirrahim and Assalamu alaikum. This is Muhammad Anas Javed from Instrumentation and Control channel. In our previous video, we understood what is instrumentation, what are instruments, process variables and process industries. Now in this video, we will study a basic feedback control loop, some new terminologies, and then we will see how a feedback control loop is implemented in practical industrial applications. Okay. So let's start with a household example of a conventional air conditioner used to control room temperature. Assume that the temperature of a room is 30 degrees Celsius and an occupant uses the remote controller of the air conditioner to set a required room temperature of 26 degrees Celsius. The remote controller sends a signal to the electronic controller inside the air conditioner. A sensor, which is usually a thermistor, tells the controller that the current room temperature is 30 degrees Celsius. The electronic controller compares the current room temperature and the required room temperature and finds out that the room temperature is needed to be reduced by 4 degrees Celsius. To reduce the temperature, the controller sends a signal to the compressor to turn on. As the compressor turns on, the room temperature starts to drop, and the temperature sensor continuously monitors the temperature and sends the signal to the controller. Once the room temperature drops below the required set temperature of 26 degrees Celsius, the controller in the air conditioner sends a signal to the compressor to turn off. But since the ambient temperature or the temperature outside the room is higher, it causes the room temperature to rise again above the required room temperature of 26 degrees Celsius. The compressor turns on again and the on-off cycle continues to control the room temperature near the required temperature of 26 degrees Celsius. Here comes the basic block diagram of a feedback control loop, and we will now implement the example of the air conditioner on this block diagram. The process variable we are controlling through the air conditioner is the room temperature. The thermistor inside the air conditioner is the sensor which measures the room temperature and sends it to the comparator as a feedback signal. And the set point is the required temperature of 26 degrees Celsius, which was set through the remote controller. Both the comparator and the controller over here were inside the air conditioner, and as the name suggests, the comparator compares the set point and the feedback signal and generates an error signal of 4 degrees Celsius, which is sent to the controller. On the basis of the error signal, the controller sends an output signal to the control element. The control element in this case is the compressor, and the output signal of the controller is a simple on or off signal. When the compressor is turned on, it compresses the refrigerant, or it can be said that it increases the pressure of the refrigerant. This high pressure refrigerant then goes through the evaporator and causes the temperature of the fins to drop rapidly, and a blower blows the air through the fins, which reduces the room temperature. The pressure of the refrigerant in this case will be manipulated variable, and cooling process of the air conditioner is the process shown here in the block diagram. A disturbance is that factor which is causing the change in the process variable. In our case, it is the ambient temperature or the temperature outside the room. The higher the ambient temperature, more will be the effort required to attain the required temperature. The final output of the feedback control loop is the controlled process variable. So now that we understand a feedback control loop well, let's take it to the next step and apply it to an industrial control loop. But before that, we will have to understand the basic layout of the instrumentation and control systems in industries. Instruments are installed at the plant site or the field, which measures different process variables and transmits the measured values through electronic signals to the control system. The control system is usually placed at a safe location away from the field and inside a building called a control room. The control system takes the decision to increase, decrease, or maintain the process variable as per the set point and feedback from the sensor. A control system can be divided into two parts. The first being the operator console, which is sometimes also called as the human interface station. This is the part from where the plant operators monitor and control different processes. The set point of the feedback control loops is also assigned and varied from such operator consoles. The second part of a control system is the control station. This is the brain of the control system where all the signals are sent and received from the field. This is where the signals are compared, analyzed, and manipulated values are generated as per predefined algorithms which are used to control different processes. These control stations are housed inside control cabinets, which are usually placed in a separate room called the rack room. Once the control system takes a decision, it sends a signal to the control element, which is also located at field. The control element generates a manipulated variable, which in turn changes the process variable. The most common industrial control element is a control valve. The control valve varies its opening in accordance to the output signal received from the controller. This percentage opening of the valve is the manipulated variable, and opening or closing of the valve in turn changes the process variable to achieve the set point. Finally, we will see how a feedback control loop may be implemented in an industrial application to control flow rate of a liquid. Assuming that diesel is flowing through this pipeline at a rate of 30 meter cube per hour. A flow sensor is continuously measuring the flow rate in this line, and a control valve, which is currently 50% opened, is acting as the control element. An operator in the control room sets a set point of 25 meter cube per hour from the operator console. This set point goes to the control station or the controller in the rack room. A feedback signal also goes to this controller from the flow sensor in the field. After comparison of the set point and the feedback signal, the controller decides to reduce the opening of the control valve to reduce the flow rate in the pipeline, and accordingly an output signal is sent to the control element in the field. The control valve reduces its opening from 50% to 30%, which results in reduction of flow of diesel in the pipeline from 30 meter cube per hour to required 25 meter cube per hour. And this way, flow in the pipeline is continuously monitored and controlled at the required flow rate. The sensor and the control element, which are located in the field, are called field instrumentation, and the operator console and control station, which are usually located in a control room, are called control system. In our next video, we will study the basics of pressure measurement. This will be all from this video. I hope this video was beneficial for you. Do like, share and subscribe to my videos. Till next time, take care and Allah Hafiz.